Hello, everybody. This is the seventh day of our crash course, and we're going to learn an important topic called responsible AI. Responsible AI is a term used to describe the design, development, deployment, and governance of AI systems in ways that prioritize ethical standards, fairness, and societal benefit. It involves understanding and addressing the impacts of AI technologies on individuals and communities, making sure they align with principles such as justice, transparency, and accountability. The increasing use of AI in critical domains makes it essential to consider its social, economic, and ethical consequences. Responsible AI aims to prevent harmful biases, ensure explainability, and provide methods for accountability in automated decision-making processes. This includes a commitment to reducing risks like discrimination, privacy violations, and security threats. Key international efforts highlight the need for responsible AI and are establishing frameworks for trustworthy AI. AI is permeating every sector, from autonomous vehicles to medical diagnostics, finance, and recruitment. As these systems influence critical decisions, the consequences of poorly designed or unchecked AI models can be devastating. Without considering ethical principles, AI can inadvertently perpetuate harmful biases, undermine privacy, or even discriminate against certain groups. For example, an AI system used in criminal justice could make biased predictions, resulting in discriminatory sentencing. In finance, an AI powered loan application system might inadvertently reject applicants from marginalized communities based on historical data patterns. Responsible AI frameworks aim to minimize such risks by focusing on fairness, ensuring transparency, building models that are interpretable, and making accountability central to AI practices. By adopting these principles, we can ensure that AI systems benefit society and reduce unintended harm. The core principles of responsible AI include fairness. AI systems should ensure that no individual or group is unfairly disadvantaged. This means actively mitigating bias in both data and algorithms and testing models for fairness to avoid discriminatory outcomes. Transparency. Users and stakeholders must have insight into how AI systems make decisions. This requires using techniques like explainable AI, where models provide understandable justifications for their actions. Accountability. There must be clear mechanisms in place for addressing mistakes made by AI systems. This involves audits, ethical reviews, and regulatory frameworks that ensure human oversight. Privacy and AMP. Security. AI systems should be built with privacy protection in mind, ensuring that personal data is not exploited or compromised. This includes data encryption, differential privacy, and secure model training techniques. Together, these principles guide the ethical development and deployment of AI technologies across industries. The distinction between AI ethics and responsible AI is subtle but important. AI ethics deals primarily with the moral implications of AI systems. For instance, it addresses questions like, should autonomous cars prioritize the safety of their passengers or pedestrians in accident scenarios? Can AI decision-making undermine human autonomy? And if so, how do we ensure accountability? On the other hand, responsible AI is the application of these ethical considerations to ensure that AI systems are designed and used responsibly. It focuses on practical approaches to solving ethical challenges, such as incorporating fairness, transparency, and accountability into AI models. While AI ethics raises critical questions about the long-term societal impact of AI, responsible AI provides actionable frameworks to guide the development and deployment of AI systems that can make a positive impact. Several organizations and governments have developed frameworks to guide the responsible deployment of AI. For instance, OECD AI principles. These principles focus on ensuring that AI is used for inclusive, sustainable, and trustworthy purposes. They emphasize the importance of human rights, fairness, and accountability in AI systems. EU AI Act. This is one of the most comprehensive regulatory efforts aimed at addressing high-risk AI applications. It lays out specific guidelines for ensuring transparency, minimizing bias, and guaranteeing accountability in AI systems. The Act categorizes AI systems by risk level and imposes stricter regulations on high-risk categories. Industry-specific guidelines, organizations like the Partnership on AI and the IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems offer ethical guidelines for particular sectors, such as healthcare, finance, and autonomous vehicles. These guidelines provide a basis for aligning AI development with responsible practices and ensuring compliance with evolving global regulations. AI systems have the potential to revolutionize numerous sectors, but they also introduce serious ethical dilemmas that must be addressed. These include how AI impacts social structures, whether it exacerbates inequality, and if it can be deployed without undermining human rights. The concept of bias is a key ethical issue in AI. Many AI systems are trained on historical data, which often contains systemic biases reflecting societal prejudices. This could result in unfair, discriminatory outcomes. To address these challenges, responsible AI frameworks seek to ensure that AI systems are accountable for the decisions they make, offering clear justification for each output, particularly when those decisions have significant consequences for individuals' lives. Ethical AI practices include continuous monitoring, auditing, and establishing feedback mechanisms to identify and rectify any harmful effects caused by AI systems. Bias in AI is one of the most critical ethical challenges. Since most AI models are trained on data, they can inadvertently perpetuate the biases that exist within that data. For example, an AI system trained on historical criminal justice data might learn that certain demographic groups are more likely to be arrested, leading to biased predictions about future criminal behavior. There are several bias mitigation techniques that can be applied to ensure fairness. Data preprocessing, ensuring that training data is balanced and representative of all groups. This can involve adjusting the dataset to prevent overrepresentation or underrepresentation of certain demographics. Algorithmic fairness, designing algorithms to optimize for fairness by using fairness constraints during the model training process. Post-processing, making adjustments to the outputs of the model after training to mitigate any discovered biases. Implementing these techniques helps make AI systems more equitable and ensures they do not disadvantage marginalized groups. A core principle of responsible AI is ensuring transparency in the decision-making process of AI models. As AI becomes more involved in complex tasks such as healthcare diagnosis or financial decision-making, explainability becomes crucial for gaining the trust of both users and regulators. Explainable AI, XAI, provides insight into how an AI system reaches its conclusions, enabling users to understand the reasoning behind its decisions. Common XAI techniques include model-agnostic approaches. These include tools like LIME, Local Interpretable Model-Agnostic Explanations, or SHAP, Shapley Additive Explanations, which provide localized, interpretable explanations for specific predictions. Rule-based models. These are simpler, more transparent models that are easier to understand compared to deep neural networks. They offer direct, human-readable rules for decision-making. Incorporating transparency and explainability builds trust and allows stakeholders to challenge or correct decisions that may be flawed or harmful. Accountability is central to the concept of responsible AI. When an AI system makes a decision that affects a person's life, it is crucial that there is clear responsibility for that decision. Without accountability, it becomes difficult to trace and rectify harmful outcomes caused by AI systems, which can lead to a loss of public trust and serious social consequences. There are several levels of accountability in AI. Developer accountability. Developers must ensure that the AI models they create adhere to ethical standards and are properly tested for potential biases, discrimination, and harmful effects. User accountability. Those who deploy AI systems, such as companies or governments, must take responsibility for how AI is applied and ensure it is used ethically. Regulatory accountability. Governments and regulatory bodies are increasingly adopting laws to ensure that AI technologies are used in a manner that protects human rights and promotes fairness. Legal accountability in AI is gaining momentum, with discussions on the need for AI-specific regulations to clearly define who is liable when AI systems cause harm. AI's rapid advancement brings both positive and negative social implications. One major concern is that automation driven by AI may lead to significant job displacement in sectors such as manufacturing, customer service, and even creative industries. Addressing this requires ethical considerations about how AI is deployed and the impact on the workforce. Another pressing issue is AI's potential to exacerbate social inequalities. If AI systems are not designed with fairness in mind, they may unintentionally widen the wealth gap or discriminate against marginalized communities. AI must be developed and deployed with a focus on reducing inequality, ensuring that its benefits are distributed equitably across society. AI systems also raise important ethical questions related to privacy, security, and individual autonomy. Ensuring ethical safeguards around AI's use in sensitive areas like healthcare, criminal justice, and law enforcement is paramount. Explainability is crucial for fostering trust in AI systems, especially in high-stakes applications like healthcare or finance. Users are more likely to adopt AI solutions if they understand how decisions are made. For example, doctors are more willing to trust an AI system in diagnosing diseases if they can see how the model arrived at its recommendation. Explainability also enables the detection of errors or biases in AI systems. By providing understandable reasons for decisions, users can spot when the system is making faulty predictions. This is particularly important in sectors like criminal justice, where incorrect predictions can lead to life-changing consequences. Moreover, transparency in AI's decision-making process supports accountability, as it allows stakeholders to evaluate whether the system is performing fairly. The lack of explainability can be a major barrier to AI deployment, especially in areas requiring regulatory oversight. There are two main types of explainability in AI: local and global interpretability. Local interpretability focuses on explaining individual predictions made by the model, whereas global interpretability aims to provide an overall understanding of how the entire model behaves. LIME, local interpretable model agnostic explanations, and SHAP, Shapley additive explanations, are popular tools for local interpretability. They work by approximating a complex model with a simpler one to show which features most influenced a particular prediction. This can help explain why a model made a specific decision, such as why it denied a loan application. For global interpretability, methods like decision trees or rule-based systems offer transparency into the whole model. While these are simpler, they may not capture the full complexity of models like deep neural networks. A balance between model-specific and model-agnostic techniques is often necessary for achieving sufficient explainability across different applications. There are inherent trade-offs in balancing explainability with the complexity and performance of AI models. While simpler models like decision trees are inherently interpretable, more advanced models like deep neural networks or ensemble methods offer better accuracy but are harder to explain. The trade-off becomes clear when considering whether to prioritize explainability or performance. Explainability often leads to compromises in accuracy or efficiency. For example, simplifying a complex model to make it more interpretable might result in a loss of predictive performance. Similarly, explainable AI techniques like LIME or SHAP can add computational overhead, making them slower or less scalable. This trade-off is critical in industries like healthcare or finance, where high performance is essential but explainability is also required. Researchers and practitioners must weigh these factors carefully to find the best balance for specific use cases. Model transparency is essential for ensuring fairness in AI systems. Transparent models allow stakeholders to evaluate whether the system is making unbiased decisions. For example, a hiring algorithm needs to be transparent so that it can be audited for gender or racial bias. Without transparency, it becomes nearly impossible to detect or correct biases in AI systems. Biases can arise at various stages, including in the data used to train the model, the modeling process itself, or during prediction. Transparent models allow for the identification of any unequal treatment across different groups and make it easier to apply fairness-enhancing techniques like reweighting or data augmentation. Furthermore, transparency is crucial for ensuring regulatory compliance. Many jurisdictions require that AI systems be explainable to ensure accountability in decision-making. Transparency builds public trust as individuals can see the rationale behind AI-driven decisions. In healthcare, explainability is crucial for clinical decision-making. AI tools like deep learning can greatly improve diagnostic accuracy, but doctors need to understand how the AI arrived at its conclusion before they can trust its recommendations. For example, an AI system that diagnoses cancer needs to explain which features of the medical imaging were important in making the prediction, ensuring that doctors can validate the reasoning behind the decision. XA techniques such as LIME and SHAP have been applied in healthcare to provide understandable explanations for model predictions. These tools allow healthcare professionals to trace why a model flagged a particular case as high risk or recommended a specific treatment. This builds trust in AI and enhances collaboration between human clinicians and machine intelligence. Without explainability, doctors may be reluctant to trust AI-driven recommendations, which could hinder adoption and reduce the impact of AI in healthcare. Transparent and explainable AI is essential to improve patient outcomes while ensuring safety and reliability. AI safety refers to the ability of AI systems to consistently perform as expected across a range of scenarios. This is particularly important in critical applications like autonomous vehicles or healthcare diagnostics, where incorrect decisions can have serious consequences. Ensuring that AI systems operate safely is a fundamental concern for developers and regulators. Robustness refers to the AI system's ability to handle unexpected or erroneous inputs. In real world scenarios, AI systems often encounter data that was not part of the training set or that is noisy or inconsistent. A robust AI system can adapt and function effectively despite these challenges. Ensuring AI safety and robustness is essential for mitigating risks associated with AI systems. For example, adversarial attacks, deliberate manipulations of input data, can cause AI systems to misbehave, resulting in harmful outcomes. An adversarial attack is an attempt to deceive AI systems by introducing small perturbations to input data that are often imperceptible to humans, but cause the AI model to make incorrect predictions. For instance, a slightly altered image of a stop sign can make an autonomous vehicle misinterpret the sign as something else, potentially leading to accidents. These attacks raise serious concerns about the safety of AI systems, especially in autonomous vehicles, medical AI, and security applications. Adversarial perturbations can drastically reduce the reliability of these systems. To counteract adversarial attacks, defensive techniques have been developed, including adversarial training, where models are exposed to adversarial examples during training to improve their resilience. Another approach is data augmentation, where the dataset is expanded with varied inputs to expose the model to a broader range of scenarios. These strategies improve AI robustness by helping the system recognize and handle adversarial inputs more effectively. AI systems must be robust enough to adapt to new, unpredictable inputs, especially when deployed in dynamic, real-world environments. For example, an AI system used in autonomous driving must be able to handle a variety of road conditions and unexpected obstacles that were not part of the training set. Ensuring generalization is critical here, meaning the AI should perform well on unseen data and maintain its ability to make accurate predictions. To achieve robustness, AI models should be tested and validated across a wide range of real-world conditions. For example, a facial recognition system deployed in different geographical locations may need to adapt to varying lighting conditions, camera angles, and even cultural diversity in facial features. Incorporating robustness into the design and testing phases ensures that AI systems perform reliably even when faced with new or adversarial scenarios. Continuous evaluation, monitoring, and validation are essential to maintaining safe AI deployment. Reinforcement learning, RL, involves agents that learn by trial and error, improving their actions based on rewards and punishments. While RL has shown remarkable success in areas like gaming and robotics, its exploration phase can lead to unsafe or undesirable outcomes. For instance, a robot learning to navigate may initially take risky actions, causing harm or damage. To ensure safe exploration, techniques such as reward shaping are used to guide agents toward desirable behaviors while avoiding dangerous actions. Reward shaping adjusts the reward function to encourage safe actions even during the agent's exploration phase. In SafeRL, constraints are also applied to ensure that agents comply with ethical norms and safety protocols. For example, a robot tasked with delivering packages should be constrained to avoid obstacles and people, ensuring the safety of its environment. These safety constraints are critical when applying RL in real-world environments, where unintended consequences can lead to significant harm. Risk mitigation is an essential aspect of responsible AI development. It involves identifying potential risks, such as unintended consequences, ethical concerns, or vulnerabilities, and implementing strategies to minimize them. This is especially important when AI is deployed in high-risk areas like autonomous driving, medical diagnosis, and defense. One key approach is to ensure AI systems have fail-safes, emergency mechanisms that allow for manual control or automatic shutdown in case of failure. For example, an autonomous vehicle should be able to stop or alert a human driver if it encounters an unforeseen situation. Auditing and testing AI systems on an ongoing basis are essential to identify emerging risks. In addition, maintaining human oversight is critical. AI systems should be designed to work alongside human operators, providing transparency and decision support rather than replacing human judgment entirely. This ensures that humans remain accountable for the decisions made by AI systems. AI regulation is vital to ensure that AI technologies are developed and used in a way that is safe, ethical, and aligned with societal values. Governments and organizations are beginning to implement rules and guidelines to ensure that AI operates transparently and responsibly. These regulations are particularly important in sectors like healthcare, autonomous driving, and finance, where AI systems can have significant real-world impacts. Governance refers to the systems and processes that ensure AI complies with laws, ethical norms, and regulatory frameworks. It includes setting up policies for AI auditing, accountability, and oversight. Effective governance helps mitigate risks such as bias, lack of transparency, or unethical use of AI technologies. As AI continues to evolve, global standards for AI governance are still being developed. There's growing momentum toward creating international frameworks that ensure AI deployment is responsible, but the regulatory landscape is complex and varies by region. The principles of AI governance are essential to ensure the responsible development and deployment of AI. Transparency is a core principle, meaning that AI systems should be explainable and their decision-making processes should be accessible. Accountability ensures that AI systems and their creators can be held responsible for the outcomes they produce, especially in cases of harm. AI should always be designed with respect for human rights and human dignity. This includes preventing AI from infringing on privacy or enabling discriminatory practices. AI systems must also adhere to ethical standards, ensuring that they are not used to violate fundamental human freedoms. Fairness is a critical principle, particularly when it comes to ensuring that AI systems do not unfairly disadvantage certain groups. In addition, privacy protections must be implemented to safeguard user data from unauthorized access or misuse. These principles ensure that AI is deployed ethically and responsibly. Various regulatory frameworks are being developed around the world to address the ethical challenges and risks associated with AI. The General Data Protection Regulation, GDPR, in the European Union is one of the most influential frameworks, especially concerning privacy rights in AI-driven systems. It ensures that AI systems respect individuals' data rights, focusing on data protection and transparency. The AI Act proposed by the European Union aims to regulate high-risk AI systems. It classifies AI applications based on the potential risks they pose to safety, health, and fundamental rights. This act proposes strict compliance requirements for AI systems that have significant societal impacts. The OECD, Organization for Economic Cooperation and Development, has also developed AI principles that emphasize the importance of transparency, accountability, and fairness in AI systems. These international efforts are helping to establish global standards for AI governance, though the approaches vary between regions. Many private companies have developed their own internal AI governance frameworks to address ethical concerns and regulatory requirements. These frameworks often include dedicated teams or AI ethics boards responsible for overseeing AI projects. These boards ensure that the development of AI systems aligns with ethical guidelines and is transparent to stakeholders. Private companies are also implementing risk management strategies to proactively address ethical concerns like bias, safety, and transparency. This often involves identifying risks early in the development process and applying mitigation strategies. For example, a company developing an AI system for hiring may implement bias audits to ensure that the system doesn't inadvertently discriminate against certain groups. To foster trust and accountability, many companies are committing to public transparency. They disclose the guidelines and processes they follow to ensure that their AI technologies are deployed responsibly. This helps build trust with consumers, regulators, and society at large. To ensure that AI systems are deployed ethically, developers often rely on established ethical AI frameworks. These frameworks provide guidelines for building AI systems that maximize societal benefit while minimizing harm. For example, frameworks like the Asilomar AI Principles or the IEEE Global Initiative on Ethics help guide decision-making in areas like transparency, accountability, and fairness. One of the core tenets of ethical AI is the emphasis on equity and non-discrimination. AI systems should be designed to avoid biased outcomes and ensure that decisions are fair and just for all individuals. This is particularly crucial in areas like criminal justice and employment, where biased AI could have significant life-altering consequences. Ethical AI must also prioritize the societal good, ensuring that technologies serve the best interests of the population as a whole. Developers must continuously evaluate their AI systems to assess their real-world impact and address emerging ethical concerns. As AI systems become more integrated into daily life, ensuring accountability becomes essential. AI accountability refers to ensuring that responsible parties, whether developers, organizations, or operators, are held accountable for the actions and outcomes of AI systems. This is particularly important in fields like autonomous vehicles, where AI decisions can result in injury or property damage. In cases where AI systems cause harm or violate laws, it's crucial to determine who is liable. Whether it's the developer, the manufacturer, or another party, establishing clear liability frameworks is necessary to ensure that there is a defined process for addressing grievances and compensating victims. Accountability also plays a significant role in building trust. When AI systems are transparent and those responsible for them are clearly identified, stakeholders, including the public, are more likely to trust that these systems will operate safely and fairly. In AI accountability, it's important to recognize that the responsibility for AI decisions doesn't fall on one party alone. AI developers create the algorithms and models that drive AI systems, but they are not solely responsible for every outcome. AI operators who implement and manage these systems play a crucial role in ensuring that the system behaves ethically and safely in real-world applications. Moreover, third-party auditors can be tasked with evaluating AI systems, ensuring that they comply with legal and ethical standards. These auditors help ensure that AI systems are fair, transparent, and free from bias. However, determining accountability in a complex AI ecosystem is challenging, especially as systems become more autonomous and interactions among multiple stakeholders, e.g., developers, operators, regulators, increase. Legal frameworks are still evolving to address these challenges. The Product Liability Framework, which holds manufacturers accountable for harm caused by defective products, may apply to AI systems. If an AI system causes harm due to a flaw in its design, coding, or operation, the manufacturer may be held liable under traditional product liability laws. However, AI systems often operate autonomously, making decisions without human input, which complicates matters. Current legal systems may struggle to address these autonomous decisions, especially in cases where an AI system's actions weren't directly controlled by a human operator. New, specialized laws may be needed to clarify liability in cases where AI systems make independent decisions that result in harm. In addition, cross-jurisdictional challenges arise when AI systems operate in multiple countries, each with its own set of liability laws. This creates complications for determining who is responsible and which jurisdiction applies when harm occurs. Legal frameworks will need to evolve to address these challenges comprehensively. Designing AI systems with accountability in mind is a proactive way to address liability concerns. One of the most important aspects is explainability, the ability for an AI system to provide understandable reasons for its decisions. This transparency helps ensure that AI decisions can be scrutinized and held accountable. AI systems should also include audit trails that log every decision and action taken by the system. These logs allow developers, auditors, and regulators to trace a system's behavior, making it easier to identify where things went wrong if the system causes harm. Incorporating ethical design principles is also essential. Ethical AI development ensures that the system's behavior aligns with societal values and respects human rights, helping to minimize the risk of unintended consequences. Furthermore, regulatory compliance should be embedded in the system's design process from the beginning. This makes it easier to comply with relevant regulations and ensures that the system adheres to legal and ethical standards. Human oversight is a critical aspect of AI accountability. Despite advances in AI, human judgment remains essential for ensuring that AI decisions align with human values and societal expectations. For high-risk areas such as healthcare or defense, where the consequences of AI errors can be catastrophic, human oversight ensures that AI systems don't operate in isolation. One approach to oversight is using human-in-the-loop systems, where AI actions are monitored or validated by human operators before being executed. This adds an additional layer of safety, preventing AI from making harmful decisions without human intervention. Training and education for human operators are essential to enhance oversight effectiveness. Operators must be equipped with the knowledge and skills to understand the AI system's behavior, identify potential issues, and intervene when necessary. This helps ensure that human operators are able to provide meaningful oversight in real time. AI transparency is about making the decision-making process of AI systems clear to both the users and developers. It's important that AI systems not only deliver accurate results, but also explain how they arrived at those results. This transparency is essential for fostering trust in AI, particularly in sectors such as healthcare, finance, and criminal justice, where decisions can have significant life-altering consequences. Explainability is closely related to transparency. It involves making the inner workings of AI systems understandable to humans, even those without specialized expertise. For example, a recommendation system in a bank should explain to users why certain financial products are recommended to them. If the reasoning is unclear, the user may question the fairness or bias in the decision. Transparency and explainability are also key to ensuring accountability. Without them, AI systems can operate as black boxes, leading to unethical outcomes, such as biased decisions that are difficult to trace or correct. Explainable AI, XAI, is crucial in ensuring that AI systems can be trusted by users, especially in critical applications. By providing understandable reasons for decisions, XAI allows stakeholders to verify that the AI system is functioning as intended and making fair, ethical decisions. This is particularly important in high-stakes areas such as healthcare, where AI-based diagnostic tools should explain their predictions to doctors to ensure that no bias or errors are present. Additionally, explainability improves the debugging process, making it easier for developers to identify issues in the system and correct them. If a model's behavior is opaque, it's much harder to improve or optimize. Explainability also plays a role in preventing unintended biases. By examining how an AI system arrives at a decision, developers can detect whether certain groups are being unfairly treated. Increasingly, regulators are demanding that AI systems be explainable, especially in areas like finance and criminal justice, to ensure accountability and prevent discriminatory outcomes. Achieving explainability in AI requires different methods depending on the type of model and the application. Model-agnostic methods are versatile and can be used across various AI models. One popular example is LIME, Local Interpretable Model-Agnostic Explanations, which provides explanations for individual predictions made by complex models, such as deep neural networks. Local explanation techniques focus on understanding why the model made a particular prediction for a specific instance. For example, in a loan approval system, local explanations can show why a specific applicant was denied or approved based on features like credit score, income, and loan history. On the other hand, global explanation techniques aim to explain the model's overall behavior and decision-making process. Methods like feature importance highlight which factors the model relies on the most across all predictions. One of the biggest challenges in achieving explainability lies in the complexity of AI models themselves. For instance, deep learning models, particularly neural networks, are highly accurate but often referred to as black box models due to their lack of transparency. These models have many layers and nodes, making it difficult to directly understand how they arrive at a specific decision. There's often a trade-off between accuracy and interpretability. More complex models, such as deep neural networks, tend to be more accurate but are less interpretable, while simpler models may be easier to explain but may not perform as well on complex tasks. Finding the right balance between these two factors is crucial. Another issue is that some AI systems are proprietary, and the inner workings of these models may not be fully disclosed by the companies that develop them. This lack of transparency can hinder explainability, especially if the AI is used in regulated industries or in high-risk decision-making areas. Explainability plays a pivotal role in ensuring that AI systems are ethical and fair. If an AI system is not explainable, it can be difficult to determine whether it is making biased or discriminatory decisions. For example, an AI system used for hiring may unintentionally favor one demographic over others, and without explainability, it's challenging to uncover and address these biases. By providing clear explanations, AI systems can ensure that decisions are made based on fair and non-discriminatory criteria. This is especially important in areas like criminal justice or credit scoring, where bias could lead to significant ethical violations. Moreover, transparent AI systems are fundamental to upholding human rights. When individuals are affected by AI decisions, they have the right to understand how those decisions were made, especially if the outcome is detrimental. Ethical AI frameworks are built on the principle of transparency, ensuring that users and affected individuals can ask questions and receive clear explanations for the actions of AI systems. AI bias occurs when an AI system produces results that are systematically prejudiced due to flawed data or design choices. Biased data is often a reflection of historical inequalities or societal prejudices, which, when fed into machine learning models, can perpetuate and even amplify these biases. For instance, an AI system trained on historical criminal data might reinforce racial or gender biases if the data itself is skewed. Such biased outcomes can lead to discriminatory practices in areas like hiring, lending, and law enforcement, potentially causing harm to marginalized groups. Therefore, ensuring fairness is essential for responsible AI. Mitigating AI bias involves a combination of technical solutions, such as debiasing algorithms and improving data quality, and ethical considerations that help guide the development of fair systems. Addressing bias requires a multidisciplinary approach, including insights from social sciences, ethics, and law, alongside traditional technical practices. There are multiple sources of bias in AI systems, with the most common being data-related biases. Bias can be introduced during the data collection phase if the data is not representative of all relevant groups. For example, an AI trained to recognize faces may perform poorly on people with darker skin tones if the training data predominantly consists of lighter-skinned individuals. Similarly, bias labeling can also impact how an AI model learns and interprets data. Algorithmic bias arises when the model itself amplifies inherent biases due to design choices, such as how features are selected or how the algorithm weights different variables. Models may also learn from biased correlations present in the training data, even if they are not directly related to the outcome. Moreover, historical and societal biases can be reflected in AI systems when they are trained on data from biased historical events or societal structures. For example, data from historical job applications might reflect gender or racial bias, which gets carried forward into AI models. To detect and mitigate bias, regular testing and auditing of AI systems are necessary. Bias audits can help identify if a model's output is disproportionately affecting certain groups. The consequences of AI bias can be profound and far-reaching. Discrimination against vulnerable populations is one of the most damaging outcomes. For instance, biased AI systems in hiring, loan approval, or healthcare may unfairly disadvantage certain groups based on race, gender, age, or disability. Such biased decisions can perpetuate existing inequalities and exacerbate social divides. Bias can also lead to inaccurate decision-making. In areas like criminal justice, biased AI models could result in false predictions about recidivism, potentially leading to unfair sentencing. Similarly, in finance, biased algorithms may offer subprime loans to minority groups at higher interest rates. Beyond individual harm, AI bias can erode public trust in technology. When people perceive AI systems as unfair or discriminatory, they may be reluctant to adopt them, and society may resist innovations that could benefit everyone. Bias undermines the credibility of AI-powered services and can harm businesses and organizations that rely on AI for decision-making. There are several approaches to mitigating AI bias, starting with the data. One of the most effective strategies is to ensure that AI systems are trained on diverse datasets that reflect the full range of populations and scenarios the AI will encounter. This helps avoid biased outcomes that arise from skewed data. In addition to diverse datasets, fairness constraints can be incorporated during model development. These constraints enforce fairness by ensuring that the AI system treats all groups equitably. Methods like equalized odds or demographic parity can help ensure that no group is unfairly disadvantaged by the system. Regular testing is crucial to detect biases early in the development process. Conducting bias audits during model development and deployment helps ensure that the system is not disproportionately affecting any group. Ensuring fairness in AI means that the system should provide equitable outcomes for all groups, regardless of race, gender, age, or other characteristics. Achieving fairness requires a careful balance between accuracy, the system's ability to make correct predictions, and bias reduction, ensuring that the system does not favor one group over others. Fairness metrics are used to assess and compare the performance of AI systems in terms of fairness. These metrics allow developers to evaluate whether certain groups are being treated more favorably than others. Common fairness metrics include demographic parity, equal opportunity, and disparate impact. Involving stakeholders, including affected communities and experts in ethics, during the development process is also key to ensuring fairness. Engaging these groups ensures that AI systems align with societal values and are free from discriminatory effects. AI privacy and security are critical for ensuring that AI systems handle data responsibly and remain resilient against attacks. Privacy focuses on protecting user data and ensuring compliance with regulations like GDPR and CCPA, which set standards for how personal data should be collected, stored, and processed. Security, on the other hand, deals with protecting AI models from threats such as hacking, adversarial attacks, and unauthorized access. One major concern is data breaches, where sensitive personal data can be exposed due to poor security measures. AI systems that rely on vast amounts of data, such as facial recognition or healthcare diagnostics, are particularly vulnerable. Misuse of AI is another risk, where systems designed for good purposes can be exploited for malicious activities, such as deepfake fraud or automated surveillance. To address these issues, organizations must implement robust privacy and security frameworks that include encryption, differential privacy, and secure AI development practices. Ensuring strong security not only protects users, but also fosters trust in AI technologies. AI systems process vast amounts of personal data, making data privacy a key concern. One effective strategy for reducing risk is data minimization, which means collecting only the data necessary for a specific task. By limiting unnecessary data collection, organizations can reduce exposure to privacy breaches. Anonymization helps protect user privacy by stripping identifiable information from datasets. However, traditional anonymization methods can still be vulnerable to re-identification attacks, where an attacker matches anonymized data with external sources to uncover identities. A more advanced approach is differential privacy, which adds statistical noise to datasets, ensuring that individual data points cannot be traced back to specific users. This technique is used by companies like Apple and Google to protect user data while still extracting useful insights. AI developers must also comply with privacy regulations. These laws require transparent data handling, user consent mechanisms, and strict policies for data storage and deletion. Noncompliance can lead to severe penalties and loss of public trust. AI security risks arise from various attack vectors that can compromise models and data integrity. One major threat is adversarial attacks, where attackers slightly modify inputs to deceive AI models. Another risk is data poisoning, where malicious data is injected into training datasets to corrupt model behavior. This could lead to AI making biased or incorrect decisions, particularly in areas like autonomous driving or fraud detection. Model inversion is another security concern. It allows attackers to extract sensitive information from AI models, such as reconstructing private training data. This is a significant issue for AI systems handling medical or financial records. Finally, unauthorized access can expose AI models to external threats. Weak authentication measures may allow hackers to steal or manipulate AI models, potentially leading to misuse or data breaches. Implementing strong security practices, including encryption, access controls, and adversarial defenses, is essential to mitigate these risks. Protecting AI models from attacks requires a multi-layered security approach. Robust training methods, such as adversarial training, help AI systems recognize and resist manipulative inputs. By exposing models to adversarial examples during training, they become better at handling real-world attacks. Adversarial defense techniques involve strategies like input sanitization and defensive distillation, which make models more resistant to subtle manipulations. These methods add security layers to prevent attackers from exploiting vulnerabilities. Secure model deployment ensures AI models remain protected in production environments. Techniques like model encryption, access control, and containerization can prevent unauthorized access and tampering. Finally, continuous monitoring plays a crucial role in identifying and responding to threats. AI security teams should regularly audit model performance, scan for anomalies, and update defenses as new attack strategies emerge. Differential privacy is a technique that protects individual data by introducing statistical noise, ensuring that AI models learn patterns without exposing sensitive information. This is particularly useful in AI applications that rely on large datasets, such as healthcare and finance. A key use case is federated learning, where AI models train on decentralized data without sharing raw information. This enhances privacy by keeping user data localized while still improving AI performance. Companies like Google and Apple use differential privacy in data analytics, ensuring compliance with regulations like GDPR and CCPA. By integrating differential privacy, AI systems can balance data utility and user privacy. Privacy-preserving AI techniques help protect sensitive data while enabling AI training and analysis. Federated learning allows AI models to be trained across multiple devices without transferring raw data, reducing privacy risks. Homomorphic encryption enables AI models to perform computations on encrypted data, ensuring security throughout processing. Secure multi-party computation, SMC, allows multiple parties to compute results collaboratively without revealing their private inputs. These techniques are essential for AI applications in healthcare, finance, and legal sectors, where privacy is critical. By adopting privacy-preserving methods, organizations can enhance security and regulatory compliance while maintaining AI effectiveness. AI governance establishes policies to ensure AI is safe, fair, and legally compliant. Organizations must align AI with laws such as GDPR, CCPA, and AI Act, which regulate data privacy, fairness, and accountability. Governance includes transparency, meaning AI decisions should be explainable, and accountability, where developers take responsibility for AI outcomes. Risk assessment helps identify biases, security risks, and compliance gaps, while regular audits ensure AI operates within ethical and legal boundaries. By implementing strong AI governance, organizations build trust and reduce risks associated with AI deployment. One major challenge in AI transparency is the black box nature of many machine learning models, particularly deep learning. These models make highly accurate predictions, but lack clear reasoning, making it difficult to interpret decisions. There is often a trade-off between accuracy and explainability. Simpler models like decision trees are more interpretable, but may be less accurate, whereas complex neural networks offer higher accuracy but low transparency. Another issue is the lack of standardized transparency practices. Different industries and regulatory bodies have varying requirements, making it difficult to implement universal transparency standards. In high-stakes applications like criminal justice, healthcare, and finance, lack of transparency raises ethical concerns. If users don't understand how AI makes decisions, trust in AI systems diminishes. Addressing these challenges requires ongoing research into interpretable AI techniques and clear regulatory guidelines. Ensuring AI security requires multiple strategies. Encryption safeguards data during storage and transmission, preventing unauthorized access. Access controls, such as role-based authentication, ensure only authorized users interact with AI models. Regular security audits help detect vulnerabilities before attackers exploit them. Adversarial testing, where AI is exposed to simulated attacks, strengthens model defenses. By integrating these best practices, organizations can minimize security threats and ensure AI integrity. AI privacy and security will continue evolving. Governments are introducing stricter regulations to ensure responsible AI use. Innovations in encryption and privacy-preserving AI will improve data security. AI itself will be used for cybersecurity, detecting and mitigating threats in real time. Ethical AI design will become an industry standard, ensuring that AI respects privacy, fairness, and transparency. Organizations must stay proactive in adopting new security frameworks to keep AI systems safe. AI development, especially large-scale models, consumes vast amounts of computational power, leading to high energy usage. Training models like GPT-4 or BERT requires extensive cloud computing, which relies on electricity, often sourced from fossil fuels. Data centers, which store and process AI models, contribute significantly to carbon emissions. Some centers consume as much power as small cities. The demand for AI-powered applications continues to grow, making this an increasing concern. To address these issues, researchers focus on sustainable AI practices. Techniques like model pruning, quantization, and efficient hardware help reduce power consumption. Additionally, green AI prioritizes environmental responsibility, encouraging AI innovation with minimal ecological impact. Companies are now investing in renewable energy to power data centers, and researchers are exploring low-energy AI architectures. Balancing AI advancements with environmental sustainability is critical for responsible AI development. Developing energy-efficient algorithms is essential for reducing AI's environmental footprint. Researchers optimize neural networks using techniques like low-rank approximation and distillation, which decrease computational needs while maintaining accuracy. Hardware optimization also plays a key role. Specialized processors like Google's TPUs and NVIDIA's energy-efficient GPUs are designed to handle AI workloads with lower power consumption. These advancements help reduce the environmental impact of AI operations. Cloud computing offers another solution. By sharing computing resources, cloud-based AI can reduce redundancy and improve efficiency. Cloud providers like Microsoft Azure and AWS are shifting to renewable energy sources, making cloud AI more sustainable. Regulations and corporate responsibility are also driving change. Governments and organizations are introducing sustainability guidelines, encouraging AI developers to consider energy use and carbon footprint when designing models. The shift toward eco-friendly AI ensures that AI benefits society without harming the environment. AI is a powerful tool for tackling climate change. It enhances climate modeling, helping scientists predict weather patterns and extreme events more accurately. Smart grids use AI to optimize energy distribution, balancing supply and demand for improved efficiency. This reduces waste and promotes clean energy use. AI also plays a role in deforestation monitoring by analyzing satellite images to detect illegal logging or land degradation in real time. Organizations like Global Forest Watch use AI to track environmental changes. In disaster management, predictive analytics helps anticipate events like hurricanes and wildfires, allowing faster response and mitigation efforts. By leveraging AI, we can develop proactive solutions for environmental challenges. Developing ethical AI starts with human-centered design, ensuring AI aligns with societal values and fairness principles. AI should be tested across diverse populations to avoid biased outcomes. Building diverse teams in AI development helps identify potential biases and blind spots. Including professionals from different backgrounds fosters more inclusive technology. Ethical guidelines, such as those from the EU AI Act or IEEE's AI Ethics Framework, provide a structured approach to responsible AI deployment. These guidelines emphasize fairness, transparency, and accountability. Stakeholder involvement, including policymakers, ethicists, and the public, ensures AI serves broad societal interests. Engaging multiple perspectives strengthens trust in AI systems and reduces ethical risks. AI impacts human rights, particularly regarding privacy, autonomy, and freedom of expression. AI-powered surveillance can erode civil liberties, with facial recognition and predictive policing raising concerns over mass monitoring and discrimination. The spread of AI-driven misinformation, such as deepfakes and algorithmic content manipulation, threatens democratic processes by influencing public opinion. Governments and tech companies must implement fact-checking and content moderation measures. Ensuring human oversight in AI decision-making prevents rights violations. Regulatory frameworks must balance AI advancements with ethical considerations, ensuring technology supports, rather than undermines, fundamental freedoms. AI is transforming education and accessibility by personalizing learning experiences. Adaptive learning systems analyze student performance and adjust content to fit individual needs, enhancing engagement and effectiveness. Assistive AI technologies, such as speech-to-text tools and AI-powered sign language interpreters, support individuals with disabilities, making education more inclusive. These tools help bridge communication gaps and provide equitable learning opportunities. AI also aids in automated grading and feedback, reducing the burden on educators and enabling faster, more consistent assessments. However, ethical concerns arise regarding data privacy, bias in AI-driven evaluations, and over-reliance on automation. Ensuring fair, unbiased AI systems in education is critical. Transparency in AI-based decisions and human oversight remain essential to maintaining fairness and trust in AI-driven learning environments. AI is revolutionizing mental health by assisting in diagnosis and support. AI-driven tools can analyze patient data to identify signs of depression, anxiety, and other mental health conditions. These tools aid doctors in diagnosing and providing timely interventions. Chatbots, such as Woebot, offer emotionally supportive conversations, providing immediate relief for individuals, especially in remote areas with limited access to mental health professionals. AI also monitors social media to detect signs of mental health issues, identifying trends and helping healthcare providers intervene early. However, ethical concerns arise regarding privacy. AI systems may inadvertently collect sensitive personal data and the risk of misdiagnosis due to insufficient training or improper algorithms. Transparency and careful regulation are essential. AI should be seen as a tool that augments human capabilities rather than replacing humans. By enhancing decision-making, AI allows individuals to analyze complex data and make more informed choices, such as in medical diagnoses or financial forecasting. In the workplace, augmented intelligence supports employees in tasks like data analysis, customer service, and even content creation. AI handles routine tasks, allowing humans to focus on more strategic work. However, AI cannot replace human creativity, intuition, and empathy. These uniquely human traits are essential in fields such as arts, counseling, and leadership. For successful human AI collaboration, organizations must build trust and transparency. Employees need to understand how AI systems work and how they contribute to decision making. AI is reshaping the future of work by automating routine and repetitive tasks across various industries, including manufacturing, retail, and customer service. This boosts efficiency, but also displaces certain jobs. At the same time, AI creates new opportunities in fields such as data science, AI development, and robotics, driving demand for skilled workers. The challenge lies in ensuring that workers can skill and adapt to this rapidly evolving landscape. Reskilling initiatives will be crucial in preparing the workforce for AI-driven roles. Governments, businesses, and educational institutions must collaborate to provide accessible training programs. Ethical labor practices are critical. AI should be deployed in a way that respects workers' rights, promotes fair wages, and ensures equal opportunities in the job market. The future of responsible AI requires global collaboration to develop international standards and policies. Countries and organizations must work together to address cross-border AI challenges and promote fairness, accountability, and transparency. As AI technology progresses, explainable AI will be a cornerstone of ethical AI systems. Being able to understand and trust AI decision-making will be essential for societal acceptance and legal compliance. The focus on ethics-first development will grow, with a priority on designing AI that aligns with human values, respects privacy, and ensures equity. AI will continue to play a vital role in achieving the United Nations Sustainable Development Goals, SDGs, contributing to solutions for climate action, health, education, and economic development. Ensuring AI supports these global goals will be a key priority. This concludes our Day 7. Thank you for watching. For more AI courses and interview materials, please go to bowsy8.com.